Hey guys, this is Naavya Vig, the AI Development and Curriculum Manager at CSE Computer Science for Communities AI series. And today we're going to be doing something a bit exciting. We are going to create our very own decision tree classifier model using the Titanic dataset. And after this video, I hope you guys have a great understanding of what decision trees are, how they can be used in machine learning, and some good implications of them, as I will show you today. Now, if you've been following the channel for a bit, you would know that in the previous videos I've talked a lot about, more so theory on machine learning, but today I thought it would be a great idea to actually get into the code so I can show you guys how this works. So one small note is that we will be coding in Python today using Google Collaboratory. It's completely free, and if you have a Google account, you can access it. So there's no cost involved in doing this, so you can follow along with me. That, and you would need some Python experience to completely understand what's going on, but if not, that's perfectly fine. I will walk through the steps. Without further ado, let's get started. So what is a decision tree? So if we go over here to this demonstration I created, let's say we wanted to make a model where we take an employer's location and their years of experience, and then we classify how much salary we're going to give them based on those two factors. Obviously, a model like that would take in more details like the employer's age, the employer's, other personal details, but this is just a very basic model to show you what a decision tree does. Let's say we have an employer living in New York, which is a more expensive area, and has like 2 years of experience. We would pay him $50K according to this model. Now, let's say they lived in Texas and had 6 years of experience working at a certain position. They'd be making $60K. So just like that, that's what a decision tree does. It goes through its nodes, checks what location is it, New York, Texas, or in some case, more nodes. It works based off many different factors, and this decision tree is key in deciding how our machine learning plays a role. And as I'll show you guys today, we will be creating our very own decision trees. Let's get into the code. So a couple things before we get started. First of all, we would need to be importing the CSV file for the Titanic dataset we will be using, and I'll also explain why we're using the Titanic dataset in a bit. So I will leave a link to the Titanic dataset CSV link, and CSV is basically a file for storing data. CSV stands for comma separated values. That is, it's going to have a bunch of tabular data that's in rows and cells, like you could open in an Excel sheet. We're going to upload it here. You could upload it just by opening your Finder, I have Mac, or your folder in Windows, drag and drop here, or upload from here. I'll do that right now. So as you guys can see here, I've uploaded my train.csv file. Once again, just drag and drop or upload from here. So now that we have our CSV file, and one more thing to note is that if you uploaded it, you would have also probably got a warning telling you that this file will be terminated after runtime. That basically means if I close the tab, open it again, or refresh, or I don't know about refresh, but basically revisit it after a while, the Google won't keep track of this data, so you'd have to upload it every single time. If you don't want to do that, you can upload it to Google Drive manually and access it from here. But that aside, we just want to learn how it works, so this should be fine for now. Next, let's get into imports. If you're not familiar with Python, Python uses a bunch of libraries, and we import these libraries, such as pandas for reading CSV files like this, and sklearn to actually create our decision trees and train the model. I'll explain all that in a bit. So just follow with me here. Import pandas as PD. What else was that? Yeah. So these are the only 3 things we'll want. Now Google Gemini is asking me to prompt a bunch more, but here's what it is. So import pandas as PD is basically telling the code to import the pandas library under the name PD. So instead of having to type pandas.read CSV, it would be much more efficient to type pd.read CSV, as I'll do in a bit. And we have train test split, I'll explain that. And decision tree classifier, once again, I will also explain that. Or I have, this is just importing it to make the decision tree. Now, basically what train test split does is, first, let's open the CSV and see what it is. So we're going to add a code block. First, let's run this so we can get all the imports done. Should take a couple seconds. And basically what we're going to do is we're going to store this CSV inside a variable that we can access. These variables are known as data frames. So data frames. So data frame, or df, equals pd.read CSV. It's going to autocomplete say data.csv. We right click here. We click copy path, and in these single quotations within this, just copy this and paste it, content train.csv right over here. Right, so this is basically what it's doing is it's going to find our CSV from the path specified. It's going to load it into this data frame. Next, we're going to do df.head. Basically, what this does is it's going to list us the first 4 elements of our CSV, so I can show you what's going on here. So if we run this, it loaded the CSV, and the head function gave us the first few elements. So the first 4 elements, or 5, if you account for index 0. We have the passenger ID, so passenger ID 1, 2, 3, 4, 5, whether or not they survived, their class, their name, their sex, age, siblings and spouses, parents and children, a bunch of other details, right? So what can we infer from this data? So in this video, we're going to be creating a model where, given all of these details except survived, so covering up survived, if I had, the passenger's age, how many siblings and spouses they had, how many parents and children, what class they were in, variables like these, if I had these variables on me, would I be able to make an accurate prediction of whether or not they survived the Titanic? So basically what we're going to be doing here is creating a decision tree that goes through all these variables, and the code in and of itself is going to be trained on this data, so it knows what would and would not be classified to either have them survive or not. Right? So that's the model we're going to be doing. Now let's move on to actually building the model. So first and foremost, we're going to remove a bunch of irrelevant things such as their name. I don't think their name has anything to do with whether or not they survived. Sex, and a bunch of other things that I'll be eliminating in a moment. So let's create a new variable, processed df. So basically it's just a new data frame that we're going to be having based off our old one. And as you can see, it's trying to autocomplete everything for me. I'll just do that in a bit and I'll explain the code. Okay, so here's what we did so far. Basically what's going on here is that, one second. Yep, basically what's going on here is df.drop, what it's doing is, it's taking our data frame and it's dropping the passenger ID, it's dropping their name, it's dropping their ticket, and it's dropping their cabin right here. Basically, these things are going to be dropped from the dataset because we have deemed them to be irrelevant, and it's going to return us the dataset without any of these things. And access equals 1 in places false, that's other things that, just basic syntax that that's outside the scope of the video. Drop NA, basically what that does is, these are only the first 4 elements, but there are going to be lots of elements, and some elements may not have complete data, and we don't want to train the model on incomplete data, so whatever rows we have that don't have, that have missing data, we're just going to automatically eliminate them. In place equals true just means that it's going to do it. It's going to actually change the data set instead of returning a new one like this one does. And process df.head, we're going to preview this. Now as you can see, we don't have our names anymore, we don't have our tickets anymore, I don't think we have our fares, we still have the fares, but we don't have the things that we don't need here, right? So now we have our cleaned and usable data. So one more thing we need to do before we actually get machine learning is, here's the thing. We have our sex and we have our embarked, but the thing is, the machine learning model runs on numbers, not on letters, not on variables. So what we're going to be doing is we're going to be converting sex to number, we're going to be converting embarked to numbers as well. So we could make male refer to 1, female refer to 0, or vice versa. It doesn't really matter as long as we implicate a clear categorization. So let's start by creating a label mapping. I'll do this code and I'll explain it once again. Alright, so here's our code so far. What the label mapping does is it's basically assigning numbers to each one. So for instance, male would be 0, female would be 1, every instance of S would be 0, C would be 0, Q equals 2. So C1, Q2. In case you're wondering, the embarked basically means what port they arrived from. So this passenger arrived from a port, I forgot the name but it starts with an S, arrived from the port starting with a C, and etc. So these are our things. If we replace them right here with this one and we preview the data again, we will get this. Now, sex has been replaced with numbers, embarked has also been replaced with numbers. That's cool. Everything is a number, so our code won't scream at us. Now we can get to the fun part of the video, that's actually creating the tree and, seeing its accuracy. So we are going to basically what we're going to be doing is creating X data and Y data. X data is basically the data we'll be giving to the machine, saying this is their class, this is their sex, this is their age, siblings, parents, everything. Everything except survived is our X data. Now our Y data is whether or not they survived. So we want to make a machine learning algorithm such that given all of these prior details, we can tell you whether or not they survived. So these are all of our X variables, and this is our Y variable. So let's do this right now. X data, oh, and it did this all for me, autocomplete, but X data is basically process df.drop survived. Basically, it's giving me the whole thing while dropping the survived on axis equals 1, basically going down, or axis equal 1 is just like, we need that for whatever reason. And then in place equals false. Once again, we don't really need to go into that too much. And then Y is only the survived one. So X is returning the data frame with everything but the survived, and Y is just the survived. All right, now let's create our train test split. So if you have Gemini enabled, it would probably do the same for you, but just make sure your code aligns with this if not. Now I'll explain what this is right now. So X train, X test, Y train, Y test equals train test split, all of this stuff. And keep in mind, we imported this function all the way up top right here. So basically what it's doing is, we need to train the data on so that the model would find the differences, would find the relations between these variables and whether or not they survived via the decision tree model that I showed here. So X train and Y train are basically, it's taking 80% of this data. So if we go over here, we have all of this data, 10 per page, and we have a lot of it. And basically what it's going to be doing is, it's going to take 80% of that data, and I'll explain why it's 80% in a bit, 80% of that data, and it's going to put it into X train and Y train. So the model can be trained on it, and the model can learn to establish the differences. X test and Y test are what we're going to be using with the remaining 20% of data we have. We're going to use that data to actually test how the machine learning model is. So we're using 80% of this to show the machine learning model this is that, and the remaining 20% so that to actually test the accuracy of that model given random data. And train test split, this is just giving it the X data, Y data to train on. Keep in mind, it's splitting it among 4 variables. Test size is 0.2, so this is establishing that 20% would be gone in test. We could make 10% gone in test if we want more to be gone in training, or we could have 90% gone in test, which is not recommended. So 20% is always recommended. And random state is once again another variable that exceeds the scope of this video, so don't worry about that. Next, we have to create our decision tree classifier. So dt decision tree equals decision tree classifier, once again auto completed. And basically what that's doing is dt.fit xtrain ytrain is basically, we have our xtrain and ytrain variables from here. It's going to create a decision tree based off of that. Now we get to the actual fun part, that is actually predicting and seeing how this thing works. Now we can actually start predicting our data. So basically what's going to happen here is we're going to call the function that gives the decision tree our test data that we have right here, and it's going to give us the prediction score of how that goes to the real data that it was. So what it knows versus what it's going to be. So test data accuracy is, so test, let's see, dt.score X test, Y test, and print the test accuracy. So essentially what that's doing is, this is going to be a decimal, so or if we want the percent variable, we could multiply this by 100. So this right here is our percent right here, and I want to round that down to 2 decimals, so we could just do this. I only want the first 2 decimals of the percent sign. So here's the code so far. We have our X data, Y data, we have our training and testing, we have our decision tree, and we're training the decision tree based off our X train variable and Y train variables. And our test accuracy, we're basically testing our test data right here and multiplying it by 100 because it is a percent. Let's see how this goes. As you can see, we have a 69 or almost a 70% chance that our test data is working perfectly. So not perfectly, it has a 7 times out of 10% chance, or 69 times out of 100, that our test data, that it accurately predicts given all of this other data whether or not it survives. Now we can also change some other variables, and I'll show you that in a bit, but for now, let's visualize the decision tree so we have a better understanding of what's going on. Now, for this one, we're gonna have to import a few more things. Alright, so here's the thing here. This code right here doesn't really matter. It auto-completed for me. You don't really need to understand this to understand the machine learning part of it. But right here, this is our complicated decision tree, which is the more complicated version of the simple version I made here. Now, if we go here, first it checks if this x is less than or equal to 0.5, which I believe 0 was male in this case. So if it's a male, then go to this side. If it's a female, go to that side. right here, if the P class, that is, I believe it was, first class, second class, third class, if it's less than or equal to 2.5 here, otherwise go here. And it basically made all of these connections itself using its depth to create our final output values. And that is how decision trees work in Python machine learning. I hope you guys enjoyed the video. It's my first coding video, so I'm pretty excited I was able to put this out for you guys, and I'll see you in the next one. Bye-bye.